So in order to find a solution of this one, we do a numerical method. We start at some random point. We call it initial point. Suppose we are given the point right here. We call it x0, initial point. Right? Then we do it this way. From this point, can we find the tangent line of this graph? This is the point x0 and fx0, right? This position. And the tangent line of this will be this line. Okay? Can we find the tangent line of this? And what is it? Is the red line here is the tangent line, which is also the linear approximation of the function here at this point, right? Now, wherever it cut the x-intercepts, okay, there's a tangent line. We can find it, right? If we can find the tangent line, can we find the x-intercept of that tangent line? Yes, just solve that one. Okay, and from linear approximation, let us call it L, which is f of x0 plus, do you remember? Can you remind me here? What is it here? F prime at 0, x0, right? Very good. Great. From this line, this is a linear line where f of x0 is a constant, right? F prime of x0 is also a constant, and we can also find this value. And x0 is a given point. We know it already. So this is a linear equation. So we can find the x-intercept of this easily by solving this linear equation, and we can find this point right here, okay? Then this point, we call it x1. So knowing x1, we can do linear approximation. We can find the tangent line of this graph at this point, okay? It will be somehow like this. We repeat the process, and we see that we can find here the point x2, right? And if we keep doing this, finally, we will be able to find that the points will come close to the solution, okay? This is a method, we call it Newton method. And from, in general, the linear approximation of x1, we see that x1, okay, from this equation, we solve f x0 plus f prime x0 x minus x0 is equal to 0. We solve this one, okay, to find x. So how can we do that? These are numbers, right? Then can we find x here? Let us eliminate the number f of x0 first, right? Then we have that f prime of x0 multiplied x minus x0 will be equal to, yes, very good. So from this, the f prime here is annoying, right? Can we eliminate it? Just divided by it, right? So, oh, here this is 0. x0 is a number, so let us eliminate that one as well. Therefore, we have x is equal to x0 minus f of x0 divided by f prime x0 here, right? So if x0 is given, the function f is given, then we can compute the right-hand side easily. So we call it, we defined x2 to be the solution here. X1, let us call it x1, is x0 minus f of x0 divided by f prime of x0, and repeat the process. So we can find, we may find a solution. This is the numerical stuff. Or in general, we have that x of the next step, n plus 1 is x of the previous step, xn, minus f of xn divided by f prime xn here. Right? Very good. And that's it. This is the Newton method. Okay? Sometimes we're not lucky. If we are given a graph like this one, okay? If we start at the point here, x0, so we see that the tangent line will be like this one. It is not a good. Let me draw another one. Okay. Let us say x0 is this point. Then from this, we know that x1 should be this point, right? This is x1. And the tangent line of this guy will be the line that touch the line here. Oh, in this case, it is lucky. It's not a good graph. It's really hard to draw. I'm sorry, but let me redraw it one more time because I want to. Sorry about that. Let me make a better graph. Thank you so much for being so patient. Okay, suppose this is the tangent line of this. Then from this is x1 and here. The tangent line of this point suppose it is this line, okay? And we see that this is x1 and here is x2. After in the initial value is x0, then the next value will be x1. It is still okay here, right? But then x2 is the intersection of the line, tangent line at x1, cut it here. x2 is far away from here. It does not come close to a solution here or solution here, right? So the Newton method fails in this example. Do you see what I mean here? Approximate the tangent line and find the next step points. Okay? So in this example, let us do one specific example and see what it is, right? Okay. Now, starting at x is equal to 2, find the second approximation. x2 to the root of the equation. X cubed minus 2x minus 5 is equal to 0. Okay? Using Newton method. Okay, before doing this, let us remind the formula of Newton method. Xn plus 1 is Xn minus f of Xn minus f of f prime of Xn. So, from the formula here, what do we need to know at any steps? Yes, f and f prime, right? So that is why we are going to compute the first derivative of this guy. Okay? Let us call this guy fx. Then the first derivative of this guy will be what is it? Yes. Will be 3x squared minus 2, right? Easy. So here is the initial guess. Okay? So the first new step, we call it step 1. X1 will be x0 minus f of x from this formula, f prime of x0. Okay? So therefore, x1 will be 2 minus f of what is it here? Yeah, 2, right? Substitute the values here. Okay, now it's easy. Just numbers. 2 minus f of 2. F of 2 will be 2 cubed minus 2 times 2 minus 5, right? Divided by, what is it? Yes, very good. So then there are numbers. You can use calculator to do it, okay? Let us try. It is 2, then here it will be 8 minus 4 minus 5 here, divided by 4 to 12 minus 2 here. Then it will be 2 minus negative 1, right? And here is 10. Therefore, it will be 2 plus 1 over 10. Therefore, it is 21 over 10. Okay? Or 2.1. You can use it by calculator. Okay? Now, we know x1, right? Let us do the x2. Step 2. X1 is 2.1 or 21.10. Okay? So therefore, from Newton method, x2 will be, do you remember? Perfect. Thank you. Okay. Now again, x1 we are given here, right? 21 over 10. So we evaluate the value of this and the derivative here. The formula will be the first number cube, which means it will be, well, I think we should use a calculator now. Cube minus 2 times the number here, which is 21/10, and then minus 5, right? The derivative will be 3x squared minus 2. So every one of you, use your calculator to compute it, please. What do you get? So finally, it will be approximately 2.0946, right? Double check it if you have the same solution. You get it? Very good. Then it's not very difficult, right? Just use the formula, apply it. So I think we're good for today, and I'll see you tomorrow. Bye, everyone.